So average value. How do you find the average value of something? That would find the average value between two things. How do you find the average value of a lot of things? Okay, so add the sum of them up, take the sum of all the things and divide it by how many things you have, right? So we're going to try and break down calculus to that simple idea, okay? And we're going to talk about units to hopefully help that out along the way as well. Okay, so you don't have to write this down, you know how to do this, right? So the average value is to take the sum and then divide, right? What if we wanted to take the average test score for last semester? Let's not. Okay. So let's say these were your test scores. You would probably think, boy, I wish. Me too. Right? So real fast, find the average for me. Like 10 seconds fast. Go. You have 4 tests. Those are the scores that you got on them. Find the average. What? 82.5%. So that's simple enough, right? That's going back to elementary school or something. What's the other word for average? Mean. Mean. Okay, so keep that in mind. Where have we seen the word mean before? The mean value theorem, right? All right. What does this mean? This means if a person got an 82, a 91, a 74, and an 83 on each one of their tests, they would get the same grade, theoretically, or they would get the same grade if that's all I graded you on, as a person that got 82.5, 82.5, 82.5, and 82.5, right? Right? Okay. So let's try and understand this graphically, though, because this will help us dive into the calculus of this. Okay. What graph would best represent the data that's given? What type of graph? Scatter plot, maybe? I would say a bar graph. Bar graph. So there's the scatter plot. But I'm going to graph it in such a way that I have a bar graph so you can see the connection between calculus. What does that resemble in calculus? Rectangular approximations. Okay. So when I add up the sum, when I take the sum of the scores, what is that equivalent in terms of the graph? What are we doing in equivalent? What? It's the area under the curve. Why? Because how wide is each rectangle? 1. So what is the area of the first rectangle? 82, because it's 1 times 82. What's the area of the second rectangle? 91. What's the area of the third rectangle? And what's the area of the fourth rectangle? And the reason those are just the same as the values is because the width of each rectangle is 1. Okay. So when we find the area under the curve, what are we doing? Finding the average? We're finding this top part of it, right? When we just find the area under the curve, those 4 numbers represent the area under the curve, don't they? You guys follow that? If you're thinking about grades, what is it called when you just add up your grades? You got your, well, like you get a 4 for an A and a 3 for a B. What is it when you just add all those up? No? That GPA is your grade point average. What do you have to do before you actually take the average? You got to add up all the points, right? Those are your grade points, right? That's your total grade points, right? This is your total test scores, right? Okay. What do we have to do to find the average? The GPA, we would divide it by how many classes you've had, right? Or you would take this and divide it by how many tests you have, right? Okay. So what we're doing essentially, graphically, is we're finding the area under the curve that gets us the sum, and then what do we have to do? Divide by the width. Well, what's the width in this case? Why is it 4? Because there's four tests, right? Or you could say it's the distance between 0, the beginning, and 4, right? You guys okay with that? Yes. Okay. So we're going to divide by the width. If I ask you to find the average value of something, you could do it this way, but this is only dealing with data points. We're going to start approaching this if we have a smooth curve somehow. Does that make sense? Okay. So now, if I were to graph the average, what would it look like? A line. So the average is what, 82.5? So it's like starting right about there and drawing a horizontal line. You guys okay with that? How do I know I'm right? How do I know it's reasonable? Because the area that is above that average line matches the missing pieces below the average line. Does that make sense? That's what it means to be an average. It means you're taking the really high stuff and getting rid of that, and you're taking kind of the really low stuff and getting rid of that. You okay? Or the really high stuff is compensating for the low stuff. Right? Okay. So, what can we say then about the area under the 4 rectangles versus the area under the average rectangle? They're the same. The area under the 4 rectangles, or the area under the curve, is the same as the area under the constant. Does that make sense? Okay, so let's look at it in terms of calculus. Do you guys need to write this down, or have you already written that down? I don't know. So the definition of an average value function, or sorry, the average value of a function, is a constant numeric value, right, that has the same area under it than the curve does. The average value of this curve on the whiteboard would be a constant value to where the area under this curve, we'll just shade it in red, has to equal the area under the constant. So where would I put the constant value? In the middle, kind of, maybe? Maybe something like this? Would you say that the area under the green line is about equivalent to the area under the blue, right? So you could say then the average value of the blue curve is equal to whatever the green line is. Okay? Okay. So how do you... Oh, let's look at another example. F of x equals x. What is that? A line with a y-intercept of and a slope of 1. So if we look at that and I want the average value, the first thing I'm going to do is find what? The area under the curve. Well, what is the area under that curve? 2? 8? First of all, what's the shape under the curve? Triangle, so it's going to be 1/2 base times height. So in this case, 1/2 4 times 4, right? So that's the area under the triangle. What do we call that in calculus, the area under the triangle, under the curve? The integral. So how would we write that? We would say the integral from 0 to 4 of, in this case, of x dx, right, is what? Is 8, right? So the integral from 0 to 4 of f of x dx is 8, because it's the area of the triangle. What we're trying to do then, that's the area under the curve. What we're trying to do is find a constant function that has what? The same area over the same interval. So what's the interval? 0 to 4. So what's the width? 4. So if it's a constant function, what would the height have to be in order to make it the same area? Y equals 2. Okay, so I know this is like wordy, but this is going to help you out hopefully later on. Okay, what I'm asking for is a constant function that produces the same area of f. The way I'm going to write this is I'm going to say g of x equals k. What does that mean? Yeah, I like k. K is a constant. So our goal is to figure out what that constant is. We're looking for a function that has a constant, that produces the same integral value. That's what that's saying right there. It's saying the integral, or the area from 0 to 4 of f of x, so in other words, the area of the triangle, has to equal the area of whatever this is going to be when g of x is just a number, a constant. And you guys did the warm-up where the constant was what? 3, right? So we're just trying to figure out what that constant is now. And we just said it a minute ago. So if the area is supposed to be 8 and the width is 4, the area is 8 and the width is 4, how high would it have to be to produce the same area? 2. Okay? So 2. Are we okay with that? So if f of x is x, then g of x is 2 if g of x is the average of f. I'm going to show you the comparison there, kind of like what we did here. I'm going to take our g of x graph and I'm going to put it into the f of x graph. So it's going to look something like this. Why is that the average value graphically? Because this top triangle is in addition to, and this little piece of a triangle is in subtraction of, right? So they compensate each other and they equal each other. Does that make sense? If you don't have that written down, make sure you do, because that's kind of the definition here. Because g of x is supposed to represent the average value of f, which means g of x has the same area under it as f has under it.
So g of x is that green?
Yeah, in this case, g of x is the green, and then f of x would be the blue.
So we're looking for a constant that in a way represents the average of the area.
It doesn't represent the average area. The areas are going to be the same. It represents the average height.
I get what you're doing, but I don't get that.
We'll get there.
I'm like, why are you doing
We'll get there in a minute. Okay, can I go on? Okay. So let's write this down for sure, because this is the actual functions, the actual relationship. And actually, let's want to explore this a little bit so you guys can see it. No, I'll do that in a minute.
When's our next quiz?
Monday? What does this give me? The integral from a to b of f of x dx gives me what? Okay. So, again, same type of thing. Okay. Let's say this is f of x. And let's do this. Let's say this is a, this is b. That integral gives me that area, right? What do I have to do with the area in order to find the height of the, or the constant value that produces the same area? What shape am I trying to form to find the average value? Trying to find the rectangle. Okay, so if I want the rectangle to produce, so we would say the area of the rectangle is length times width, right? I'll just use this. We'll say base times height, right? You guys okay with that? Okay. Area is base times height. Well, if I want my rectangle to have, these capitals here, if I want the area of my rectangle, what are we saying? Maybe something like this? Does that seem reasonable? Okay. Because this might compensate that. What is the base of that rectangle going to be? B minus A. Okay. And what is the height of that rectangle going to be? Well, it might be. It might be that point. It might not be. We don't know. It's going to be whatever the function is, right? Whatever the height is. We'll call it h. Okay, we don't know that yet. But this is the area under the red curve, the constant, right? Remember, the area under the red curve is supposed to be equal to what? The area under the green curve. Well, what function represents the area under the green curve? Not f of x. It represents the area. The integral. So this is the area under the curve, or sorry, the area of the constant function. This area has to equal what? So we're going to say b minus a times whatever the height is. Height is going to be the constant value, right? That's going to be equal to the integral from a to b of f of x dx.
So H is K.
Yeah. Let me do that. So you're right. So k is the constant, right? So this will be k, and then this will be
What is the red line for? Or what is
k represents, that red line represents the constant value. So the area in the red portion is b minus a times whatever the function's value is, k. That's the area of the red region. This, the integral from a to b of f of x, is the area of the green region. So what would I do to solve for k? So we would say k equals the integral from a to b of f of x dx all over b minus a. This is to find the average value. K is the average value. Okay, so the integral is the area under the curve from a to b. We have to take the area, and since I want a rectangle, if I have the area and I have my width, how do I find my height? Divide. So this is the area. We divide it by the width, right? So b minus a is that width. So we're going to take those and just divide it. So the average function is equal to that. Okay. Now we don't normally write it like this, even though this helps us understand it a little bit more. We write it like this: 1 over b minus a times the integral of f of x dx. Write that down if you haven't already. That's important. Okay. So that's that. That's the average value function. I want to try and apply this, and hopefully it makes a little bit of sense. Okay. Let velocity be given by 3 cosine of t plus 7 along the x-axis over the interval 2 to 7. What is the average velocity? Haven't I asked for average velocity in the past? What function did I give you? What was the given function in order to find average velocity in the past, in last semester? If I'm looking for average, okay, let's take a step back. If I'm looking for average velocity, we would say that is equivalent to the, what's another word for velocity? Yeah, we're taking a step back. We're going step by step. Average velocity is average rate, right? Which is equal to just the slope. But the slope of what? What? The position function. You get what I'm saying? So let me give you an example here. Let's take a step back from that. And I'm going to say x of t represents position. I want you to find the average velocity over that interval 2 to 7. What would you do to find the average velocity? This is a good review. Wait a minute. If I take the derivative, what am I finding? Wait a minute. What's the word though? If this is x of t represents position. Oh, let me do this. Let's say x of t is that 3 cosine of t plus 7. If x is position and I take the derivative, what am I finding? What kind of velocity though? Instantaneous velocity. There it is. Remember, taking the derivative is finding the velocity at a point. When I want the average velocity, all I'm asking you to do is find the slope between the 2 points. So the average velocity here would be what? No, not v of 7. X of 7 minus x of 2 over 7 minus 2. Are you guys okay with that? But that's the approach because this is position. You okay with that? If I wanted instantaneous velocity, what would I have to do? I would say instantaneous velocity when t equals 7. Then you would say take the derivative, so you'd say x prime of 7. That's the difference between those two. You okay with that? But I want to focus in on this one. Let's go back a step. See how I gave you position? And I said find the average velocity, so you found the slope, right? What did I give you over there in the actual problem? I gave you velocity, and I'm asking you to find the average velocity. So a lot of times students will confuse this. They see average velocity. Okay, I just find the slope. No, you find the slope of position to find average velocity. If I give you velocity, how do you find average velocity? I don't know. Okay, well, this is going to go in circles here, but it's worth a shot. If I give you velocity, and I want average velocity, I take the antiderivative of velocity, and I end up with what? So I take the antiderivative to get position, right? And then I take that position, and I find the slope of that. Does that make sense?
Yeah.
The problem with doing it that way, when you take the antiderivative, you have a plus c, so you need to have a what? You have to have an initial condition, and I didn't give you that here. Does that make sense? So that's a way to do it, and in fact, I would argue that the c is going to cancel out because of the math that you're doing, and you can explore that separately. But let's look at units to try and understand what's happening here. Let's go back to basic stuff. Distance equals rate times time, right? Yes? Distance is represented by what function? X of t is equal to what's represented by rate? Velocity times time. You guys okay with that? We are trying to find the average velocity, yeah? How would I solve for velocity here? So we're going to say v of t is equal to x of t over t. You guys okay with that so far? I mean, that's just basic algebra stuff. We're trying to make the connections here. Yesterday, we kind of made a very small connection between integrals and derivatives. In one of the warm-ups, there was two different ways to approach it. I gave you velocity, and I asked you to find a distance traveled. So what did some of you guys try and do? I gave you velocity, so you took the antiderivative, right?
Yeah.
And then you plugged in the points and everything else, right? The other way was if I gave you velocity, what do you do to find the distance traveled? You take the integral, right? Because the area under the curve is the distance traveled. You follow what I'm saying? In other words, x of t is represented by what? The integral of what? How do you find x of t? You take the integral of v of t over what interval? In this case, 2 to 7, all over, what's the time? 7 minus 2. And that looks very similar to what we had on the board a minute ago, doesn't it? Okay. But I'm trying to make the connections here. Let's look at units. What is the, blah, blah. I don't want to say this. I can't make that connection yet, but yeah, we're going to have to talk about that later. But you guys get how this is the average velocity here? Given what function? Velocity. Velocity is the integrand. When I take the integral of it, I end up with a position or a distance traveled. And then I take the distance traveled and divide it by the time. Distance, here's what I wanted to say. The distance is what kind of units? Maybe miles, sure. Over minutes or whatever the minutes are. And so velocity, that makes sense. If I'm taking this value, which I know is position or distance, and dividing it by time, I'm getting the units correct for velocity, because velocity is something per something, right? Miles per minute or whatever it is.
But the formula will always be
No. Well, what do you mean, v of t?
like that.
No, this is the average value. This is the average velocity when given what? Velocity. This is the average velocity when given
The
position.
position.
See the difference between the two?
Yeah, so there's only two.
Oh, there's a lot of different ways I could say that, okay? So let's do this one. You guys get your calculator out and let's do this. The lower bound is 2, the upper bound is 7. What would the equation be for this then? The average velocity is... Okay, but remember, we put that 7 minus 2 up front. So the average velocity is that, and then times 1 over 7 minus 2. It's just like derivatives. Like if I asked you what is the velocity and I give you the velocity function, you would just look at the graph. But if I asked you what is the velocity and I give you the position, you'd have to find the derivative, right? It's that same relationship there. Okay, 6.848. Okay. 849. Are we okay with this? Okay. I want to make this point. What does the 34.243 represent? It does represent the integral, but what does it mean? It means how far the particle has traveled over the time interval, right? If I want to figure out velocity, I have to take the distance that it traveled and divide it by time. And so that 34 represents the distance it traveled, and the 5 represents the time. You guys okay with that? That's all this is saying, okay? The 34.243 is the distance traveled, and then the 5 is the time. And the 5, how did I get the 5? I take the upper bound minus the lower bound. Okay. Go ahead and try these. Give you a few minutes. What is the average value of these functions? And then I want you to look at the graph to see, to try and understand what that's doing graphically. Make that connection in your brain. It's a calculator problem. No. I'm serious about this graph, especially on number 1. Did you notice something about number 1? On the first one, did you guys get an answer? 0. So what's the equation? No, I know the integram, but what am I writing down to find the average value? 1 over. No. It's the upper bound minus the lower bound. You guys follow me on that? Then what? Uh-oh. Come on, guys. What's next? What's the equation that's going to give me the average value? The integral from negative pi to pi of sine of 2z times e to the 1 minus cosine of 2z. And then times dz, or dz after that's all said and done. What did you guys get as an answer? 0. Why? If you look at the graph, and you should have done this, but if you look at the graph from negative pi to pi, I don't know what this looks like. It's something like this, I think. And then it does like that. Something like that, right? All right? You guys are killing me.
Yes, I got that.
So the area here compensates the area there exactly. I didn't graph this perfectly. And the area here compensates for that. So the average value is just the x-axis. Does that make sense? Okay. What did you guys get for the second one? Negative what? Negative 1.6209. What's the equation? It's 1 over 5 halves minus negative 1. The integral from and I'm just going to call it f of t dt. And what did you get? Negative what?
1.6209.
Are we okay with that now? Yeah, I need to see this. Okay. Why is this a negative answer? Why is the average value negative? No, the width is positive. If I'm going from negative 1 to 5 halves, I'm going that way. Because there's more area underneath the graph than there is above the graph. Just imagine taking the average of your test scores where you could actually get negative values for your test score.